Entropy is a multifaceted concept, and it is very hard to define with a single sentence. Nevertheless, we do try. So when we talk about the entropy, we might say that it is a measure of disorder, or a measure of randomness, or a measure of states a system can have. I prefer to think of it as a measure of states a system can have. Imagine this box. It has 4 available spaces, and I have placed a single egg in one of the spaces. What are the possible states for this particular system? Well, I can move the egg around. So this would be a state, this would be a state, and this would be a state. So these 4 states represent the entropy of the system. Imagine a bigger box. So this box has 8 available spaces. And once again, we could move this egg around. And if we did that, we would end up with 8 possible states for this particular system. Therefore, we could say that the bigger box has a larger entropy than a smaller box, because the bigger box, the bigger system here, can have more possible states. I would also like to talk about a common misconception when we talk about entropy. When we talk about entropy as a measure of disorder, people will often give the following example. They will say that if you have a room that is messy, and if you were to compare that messy room with the very same room when it is tidy, the messy room has a bigger entropy than the tidy room. This is not correct, because in this particular case, the room represents the system, and therefore messy and tidy are simply states of the system. Now sure, you could say that there are more messy states than there are tidy states, but overall, all of the messy states and all of the tidy states represent the entropy of the room, the entropy of our system. And finally, I would like to say, and I should have probably led with this, that the symbol for entropy is S, therefore change in entropy is delta S. So this is entropy, and it should not be confused with a similar sounding enthalpy, which is symbolized by H, and the change in enthalpy is symbolized by delta H. So S for entropy and H for enthalpy.